There are millions of oil and gas wells globally, many reaching the end of their productive life, or decommissioned and abandoned. While many of these wells do not have sufficient temperatures for viable geothermal use, or have integrity issues that would disqualify their reuse, others may be viable candidates for redevelopment into geothermal resources for heat or electricity production. The proposition of reusing existing wells has gained traction recently because it presents the opportunity for oil and gas entities to transition their existing hydrocarbon assets into clean energy without the need to drill new wells. So, what are the opportunities and economics associated with well redevelopment? How can entities assess whether they have viable well candidates for geothermal development? And what are the risks and challenges associated with this approach? Let's explore.
Hello, everyone. Welcome back to the continued panel discussions of Pivot 2021. In this session, we're going to continue to explore the potential and budding relationship between oil and gas and the geothermal energy field with this panel titled Oil and Gas Well Repurposing, Turning Liabilities into Assets. So this panel has a broad background from drilling execution of high pressure, high temperature systems, subsurface oil and gas development, and even a lifelong commitment to the academic study of the thermodynamics of the earth. And even some of these panelists have actually made that transition from oil and gas to the geothermal development. And today what we want to focus on is exploring that transition from oil and gas to geothermal development as the title entails. So just a quick note or a quick background. When we think about the oil and gas development, we know that there's a whole bunch of wells out there, right? So just looked up some numbers. According to the EIA and the EPA from 2019 and 2018, the US has approximately 970,000 producing oil and gas wells and between 2.3 and 3 million abandoned wells, respectively. So from a scope perspective, this is a lot of wells. And what we're hoping to do in this session is to not only address some potential challenges, which are both of the economic and technical spirit, but also what are solutions to these challenges? What questions should we be asking? And then how do we address those? So we want to do this by having an honest conversation and understanding these challenges so that we can overcome them and push forward this development into usable and scalable solutions. So it's clear from a lot of the panel discussions that we've had already that innovation is key. We've heard that word several times over and again about innovation. And a great example of this is in the shale oil and gas field. So when we first started drilling these wells, we went horizontal, 5,000 feet, then 10,000 feet, then 15,000 feet, then 20,000 feet. And we completed them. And then we actually started making money on those, even with such high well costs, and we innovated our way down to suitable costs. So there's no doubt that innovation is key and that application of innovation can be applied to geothermal. So before we get into the panel, I'll do a brief introduction of myself. My name is Matt Silvio, and I'm currently a geologist with Pioneer Natural Resources. And I have a broad experience with planning and executing oil and gas wells, primarily in the unconventional field, as well as working with different data types from reservoir engineering, traditional geologic data sets, completions and drilling data, and even production ops. So my goal is to integrate all of these data sets to come to the table with data-based solutions to complex problems. So that's what one of our hopes is of this panel, is to address some of these problems that we see today, if there are any, and then to push forward and to educate the audience as well as the oil and gas industry on the potential of this field. So it's my pleasure to introduce our panelists, and we'll start off with Carl.
Thanks, Matt. So I'm Carl Farry. I'm the Chief Executive Officer of Seraphy Energy. We're a new energy startup company, really started around about a year ago. All the background of the founders primarily are from oil and gas. So we're really sort of coming at the geothermal space from the oil and gas lessons learned area, and really just trying to make an impact change to bring geothermal anywhere to a reality, or anywhere and everywhere to a reality. Taking some of the experience from oil and gas, but primarily looking at what we can do with these redundant assets and liabilities that are currently there.
Great. Thanks, Carl. So then I'd like to introduce Bob Pilko.
Howdy, bud. My name's Bob Pilko. I'm with Blade Energy Partners. And I've been in the oil patch, golly, since just about 1978, originally with Schlumberger. And then with a series of service and consulting companies, always upstream. And here at Blade, which is a 21-year-old company, provide external relations and help to lead the geothermal development division. Geothermal, when I first started to look at it over 10 years ago, realized is a technology and an energy source which can be applied the world over as long as we have a geothermal source that's within an economic depth from surface. So I appreciate 2021 inviting me here, Matt moderating, and the panel colleagues. Thank you very much.
Thanks, Bob. We appreciate it. Next, I'd like to introduce Maria Richards.
Hello. Oops. Hello. Can you see me?
Yes.
So hi, this is Maria Richards, and I'm with the SMU Geothermal Lab. I am the coordinator of that lab for the last, well, over 25 years at this point. I also research, and the research has been focused on finding the resources of geothermal energy across the country. And in doing so, as we worked on things like the geothermal map of North America, I started realizing how much energy is stored within the sedimentary basins. And that heat is something that I started asking questions and saying, how come there's no geothermal exploration in Texas? And so I found that by living in Dallas, I went to the oil and gas industry and companies in that area, and then continued to expand, and now have worked for about 15 plus years with the different industries and companies in the oil and gas, trying to learn more about how to make this happen. So I'm really excited that Pivot 2020 and Pivot 2021 are being so successful, because I feel that the oil and gas industry, helping the geothermal industry and working side by side, is one of the best ways to get our sedimentary basins to be explored. I also worked with the NGDS, the National Geothermal Database System, and in developing and creating that for the SMU lab, I realized there's so much data out there. And so Matt, your comment about data is so true, that we have a lot of information that can be used to get this industry moved into our sedimentary basins. So thank you for inviting me and having me on the panel.
Excellent. Thank you, Maria. And next, I'd like to introduce Selena Derksweiler.
Great, thanks, Matt. It's good to be back at Pivot. I was here last year on another panel, and it's always wonderful to talk to colleagues and try and solve some of the toughest problems in front of us. I am CEO and co-founder of Transitional Energy. We really are focused on distributed geothermal energy, specifically from oil and gas infrastructure, both through a consulting and contract operator role. And so I've spent 22 years in oil and gas at a variety of different size companies, both large public, small private, as well as startup companies. Half that time has been spent in conventional water flood and thermal flood assets, and the other half in the unconventional world. And I really take a stand around thinking about energy in a broader view, that it doesn't need to be an us versus them, that some of the best kinds of innovation is really around architectural innovation, the idea that you can take the Legos apart and put them back together in a different way. And so I'm really excited to see the continued conversation around this. And I started my career with Oxy, where all we did was reuse well bores on the Thumbs Island. So the idea of reusing well bores to transition our energy infrastructure is really exciting. So I'm happy to be here on this panel today.
Great. Thank you all for your introduction. So the way that this panel is structured is, what we want to do is give a little background and sort of define that scope a little better, as far as what we mean by well reuse and sort of what is the resource out there. Because in the oil and gas industry, we do target different things than the geothermal industry would target. So there is variation as far as the environmental working conditions, as well as, to borrow a phrase from unconventionals, the sweet spot. So what I'd like to do is start off with Maria. And so given your background through research, as well as your recent experience with, I believe, Petrolearn, what are prospective areas for this reuse of wells? And, from geologic and thermal conditions within sedimentary basins, i.e., can we go to any sedimentary basin where there's oil and gas development, or are we going to be limited based off of the heat flow that's there? Once again, because we do know that there are shallow oil and gas reservoirs as well as deep ones. So if you could just do a brief comment on, even just US, where do you see this sort of technology being applied for that reuse operation?
In terms of sedimentary basins, they definitely vary in that typically places like the Permian Basin are considered cold, and that you can go really deep. You have to go 20,000 feet to get, into some of those oil and gas reserves. And yet, if you are overlapping the oil and gas industry infrastructure where there's heat within even the surface, as well as what's in the ground, you have a lot more opportunity to develop even in some place that is considered cold. But typically when we talk about things like co-production or geothermal, if we're talking in Fahrenheit, we're looking at temperatures that are at least 190 degrees Fahrenheit or hotter. And obviously the hotter it is, the better it is. And then along with that is just the water production. And so sedimentary basins, like Oklahoma, tend to have lots of high water flow, but they're going to be lower temperature. They're in that 150 to 170 range. And so that's when it is too cold at this point. But at this point is what we want to focus on.
So in your opinion, from Texas, is there any place in Texas where you could see that has the right operating conditions for well reuse?
Very much so. That we have done, Joe Batir and I have done resource assessments on the Gulf Coast and South Texas and East Texas. And by far the South Texas is significantly hotter than everywhere else and in shallow depths. And then all along the Gulf Coast, you also have the geopressure, which is an advantage. And that also has areas that are definitely, so we're talking, some of those areas are over 300 degrees Fahrenheit and on up. And so at shallow depths, reasonably geothermally shallow depths.
So much like geology, it's complicated.
Yeah.
As far as where we can go, it's not the same everywhere. So there is an idea of an exploration opportunity as far as what are the right operating conditions. Thank you. So next, I'd like to go towards Selena. So you've made that transition from oil and gas to geothermal, and really, from the sounds of it, this is kind of your bread and butter, is conversion of oil and gas wells into geothermal assets. So, I guess as brief as can be, I'm sure it's very complicated, is what are the opportunities as well as some risks in converting your wells or, an operation from an oil and gas asset to a geothermal asset? And with that too, could we only use recent wells, or can you use abandoned wells? And, any real world experience from transitional energy would be great.
Sure. So yeah, I think that, I think it's really important to make sure we're talking about the same language. That has been a huge thing as I've moved through this space, is that depending on who you're talking to, depending on your audience, you may not always be saying the same thing, even though you're using the same words. And so I think that when we talk about, converting or transitioning from oil and gas to geothermal, I actually don't see it as a full transition. I see it as a co-production. I see it as an entire system of energy to think about. So as my background in reservoir engineering, thinking about how to move fluids in the subsurface is something that oil and gas operators know how to do. They know how the flow is going to be up at the surface, how to design those facilities. But we know that oil and gas typically focuses on producing more oil, not water. Water can have rel perm effects in the subsurface, and you can actually shut off your primary production. So in that case, you can convert wellbores fully to geothermal. In other cases, you can just pull the heat off that goes up to the surface, or that we spend money to cool so we can send it through our facilities. You can actually generate power. And now there's a lot of technology advancements in the ORC engine cycle. And so you can actually generate power power at lower temperatures as long as your ambient temperatures are cool. So where you have hot fluids in the subsurface, or maybe not as hot, if you have cool ambient temperature, you can actually generate power, that differential in temperature. So it's important to look for that. I think the economic risks really, though, come down to, I think we're all really good at finding fluids in the subsurface, thinking about how to produce them on the surface, being efficient with all of that. Flow and temperature are right on, Maria, and I agree completely on that. I think that the challenge is then, who are you selling your commodity to? Where is it? A power? Is it a direct use for the heat? That's the economic case, the business case for what you're doing. So what is the need of the project? Does the operator need power on location? Are they replacing diesel generation? Are they wanting to sell to the grid? Are you wanting to convert your entire asset to geothermal? I think it really matters what the goal is for the project. And each project is just unique, as each oil field is unique.
Okay, great. Yeah, I mean, from the sounds of it is, there are different terminologies in this field as far as what we would use. I mean, today alone, we've heard of electricity generation to direct heat to, using geothermal for greenhouses. So those are all, like, to me, fairly different utilities and may require different, once again, operating conditions within the subsurface. So once again, it can be kind of complicated. As far as the utility of the wells, and we'll go into this a little bit later, is from your experience, have you seen any utility of, like, we'll call them old wells from the idea of, pre-90, that'll be like ancient wells, right? Like, or do you really try to focus on, more newer wells with more newer completions, or, is there an age limit that you think would be cut off from a reuse perspective?
Well, given that my career started at Thumbs Islands, the islands were built in the 1960s. So all the well bores are that old. And the whole point is you have a limited number of well bores to use, and you just keep reusing them. So it's really more important to understand how to assess the mechanical integrity of the well bores. Obviously, there's regulations around mechanical integrity. That data is public, so data is going to be important there. There are ways to go through and look at cement integrity, what kind of cement operations occurred originally, what kind of acid jobs were done over time. So it's really more important, the technical evaluation of the well bores. I would say, generally speaking, if you start to get into some of those old 1950s well bores, we've seen a lot of mechanical integrity issues more with the flow lines than the well bores themselves. So it's really the rest of the infrastructure that becomes challenging. Well bores themselves, you can re-enter them. I think it's much easier to enter well bores that are already producing. And even you can actually go in and test that casing integrity helps a lot. But it isn't necessarily just a line that you draw and say, anything before 1990, don't use. It really is evaluating the well bore integrity. And that's a skill set that production engineers have.
Excellent. Thank you so much. The next question I would like to direct towards Carl. So Carl, in your experience, what is the size of the prize's potential impact on a local, regional, global scale as you view it from this conversion, and sort of the implications of a successful program? And would those, kind of along the same lines, would those be limited to just thermal energy like direct heat, or electricity generation? Based on your experience too, have you been able to see the utility of both vertical and horizontal wells in this situation, given that a lot of developments today, especially non-conventionals, are laterals, which may have different constraints as far as reuse?
Yeah, I think that's a good question, and I think Selena sort of touched on a few points there related to this, and I think the key is really it's like every situation is different, so there's no one situation you can say sort of you can apply to everything. So our approach is really to look at what's on offer, whether they're on what type of wells they are. Really understand, first of all, them wells, because, one thing we need to remember with oil and gas wells, they weren't drilled for geothermal, they were drilled for oil and gas. So, the actual completion sizes of these wells generally against us from the beginning, so they're a lot slimmer, lot smaller in respect to completions that we would normally deploy in the geothermal world, where you're looking for more space, more heat, more extraction in a bigger well. So generally, our approach would be to look at, you know, each well on a case by case basis, and you know, again, it's about using the thermal gradients that you have to have at hand. So they're not all going to be for electricity. And I think this is one thing we need to understand, you know, that, you know, electricity is the cream on the cake really for this type of approach, but heat can be used, and heat is commercial. And I think the more we go forward in the future with you know, carbon taxes and various other things, or tariffs and other things that move in, you know, heat's going to play a bigger game and a bigger part of this, for all the different things you mentioned earlier, from agriculture to, you know, district, you know, centralized heating and things like that. And there's also different ways of selling it. So, you know, the key we always look at is, first of all, it's you know, location of the wells and whether they're suitable. So looking at the integrity issues of the well, if they're good to be used for a start, if they are, how long they can be used for. And then the next real approach is really, what is the offtake? Where are you going to take it to, and who's going to buy whatever energy you produce? Because that's you know, really part of the puzzle, and the key part of the puzzle, because you can have the best wells in the world, but if you've got where to stick the energy or the production from them wells, you know, you've got nothing at the end of the day. And nobody wants to have transmission systems and, you know, large distribution networks to, you know, plugging into these things. You need to use these locally where you have the wells as best as possible, you know, ideally behind the fence of where the wells are, so you can put the energy straight into something without actually having to connect it to anything outside. Because the moment you do that, you involve multiple layers of complexity with, you know, tie-ins to grids and all sorts of other things.
So from the sounds of it, and I'm actually gonna move to Bob next, but given the complexities of different time periods, you know, different directionalities of the wells, just different, pretty much everything developments, like we had mentioned, oil and gas was targeted differently. There seems to be a case-by-case basis, which from the impact on you know, think about it just a jobs perspective, sounds like service companies in this aspect would really aim to develop some, how do we assess the viability of conversion of wells, sort of thing, just given the dynamic nature of how these wells and how you would choose candidates. And with that, we'll turn to Bob. So given your experience in this high temperature, high pressure drilling environment, now thinking about converting these well bores, whether they are high temperature, high pressure, or they are the lower temperature cold basins that Maria had referenced, you know, what do you see from an execution standpoint? And I know that we're not re-drilling these wells, but is there anything from your insights that you could give us that what are common issues that you could see arise when trying to re-enter a well bore? And that could be anything from borehole conditions themselves, scaling, casing integrity, especially within these sedimentary basins who can have a lot of precipitates come out.
Well, thanks for the question, and appreciate what the other panelists have mentioned and gotten into. Here's the situation. Number one is wellbore integrity, and that's the key. However, to get there, it depends on the type of well and where we're going with it. So, for instance, when I look and use the term drilling in production, I look at the well on a holistic basis, including getting down to it or recompleting it or doing a sidetrack, getting to the geothermal target, and the full completion aspect of it to harvest that geothermal energy and get it to surface. That being said, what the wellbore integrity of any well is always a question, and it has a number of things, a number of aspects that we would look at even from an oil and gas perspective. First of all, what's the well configuration? What's the well history? It was mentioned the well, previous well production, any corrosives, that kind of thing. Was the well stimulated? And if it was, in which way, and getting the well files, hopefully there's good well files. And what's the well status today? Is the well shut in? Why is it shut in? Is the well producing? Would we like it to be producing more? Perhaps it's a geothermal well. And the geothermal well, we would like to get back on production or produce more. And getting back to Selena's statement, what's the real purpose? So we may look at a conversion just for geothermal energy, or we may look at the purpose for a combination of co-production, which is both produce hydrocarbon and geothermal harvesting, downhole thermal harvesting. So there's so many factors, but being able to assess the wellbore integrity in the current state is critically important, including allowing us to do further assessments. And the thermal well engineering and the thermal design is something that one has to look at from a critical and a complex well perspective, especially when we go deeper and deeper into higher temperature formations. The casing strings may not be originally designed for anything but production, and they may have been designed so long ago, and the cementing systems so long ago may not have the integrity. So we have to take a look at that. We have to do additional tests, and it's a new look at a old situation.
So I guess with that in mind, I think, given the everybody's comments on this, just sort of a rapid fire question round is, given the complexity that we've discussed, like what would be your top 3 considerations when trying to re-enter a well or trying to convert a well? And, this is open up to everybody. I mean, Bob, you kind of already mentioned some, so I guess, we can go to Selena. Like, what would be your top 3 that you need to investigate first?
Temperature, flow, and the market. I call it the power market or heat market.
Okay. Carl, what about you? Would you agree?
That's the same with me. We'd look at the well temperatures, bottom hole first of all. Integrity of the well would be probably primarily along with that. And then, who potentially we could take the offtake to, depending on what that temperature grading is. Remember, the bottom hole temperature also, varies a lot from what you can actually get at the top. So, depending on how deep the well is, you might have a really good bottom hole temperature, but if you've got a long travel distance, you get losses in that. So it's a combination of bottom hole temperature and also what you can actually get to the top side on a optimum basis to produce energy. And like I say, it's not always about electricity, and I think that's probably a very different approach that we're always taking. We treat electricity to somewhat as the cream on the cake, but if you can get that, that's the sort of golden goose. But generally we're looking at to commercialize anything above 30-40 degrees. It's ideally because it all has a value if you can put it in the right place.
Yeah, so I mean, to follow up on that, with electricity being the cream on the cake, right? We think about marketing and getting the resource, no matter oil and gas or, maybe geothermal, the heat, the electricity, getting it to market. So one of the thoughts is with oil and gas, you have almost a directly transportable source of energy. The energy is packaged in these hydrocarbon fluids, and they can be transported in relatively stable states. With geothermal, and correct me if I'm wrong, but one of the disadvantages is you can't package that energy in a nice stable solution and then transfer it. So there has to be an infrastructure built for an electrical use, or it has to be close by. So how would you utilize that resource, or would you need infrastructure changes? Because as of right now, we have batteries, we have all sorts of surface operations. Could you utilize those, or would you have to build something new?
I think, if I can just answer that, first of all, I think again, it really depends how much you're trying to produce. If you're trying to get, a few, couple of megawatts out of a hot well, which is probably doable nowadays. I mean, the optimization of that process moving forward is going to grow as we get better ORC technology, etc. But at the moment, it's sort of quite limited of what you can get with each well, to a certain extent. But using it in situ again is we talk about battery storage, we talk about all sorts of other things as well. But there's ways now with the right, if you're producing electricity, you can do on-site electrolysis for green hydrogen. You can do other things like that, which are equivalent really to a battery storage process, but just using the energy in a different way, because you have then got a liquid that can be somewhat transported or used for various different applications, i.e. for local transportation, or even powering generators and things like that for using to produce higher efficiency electricity. But again, I think again, it's the importance of the offtake is very critical in this. And there's there's millions of wells around the world. I mean, we've just rough calculations. If you look at just if you were to get half a megawatt thermal energy out of every orphaned well around the world, that's in the terawatts of energy moving forward. So it doesn't have to be all about electricity if we're in this sort of decarbonisation world and mentality that everyone's trying to help. And there's also the ESG value, so the ESG value is massive when you start adding in agriculture, jobs, and all the other stuff that will come into this play. So I think we've got to be sort of conscious of that as well.
Yeah, exactly. You can't, what's the worth of the resource if you can't utilize it? So Maria, did you have a comment that you wanted to make?
Yes, just the idea that what's at the surface can often be more important than what's below ground. And the fact that we all think about high temperatures and high flow rates, but now wells are being looked at to say, if we have a solar array or solar troughs or things like that at the surface, or even wind as well, can we now use our wells as a geothermal storage site? And so that opens up fields that would not be hot enough for electricity. In reality, the direct use of that well could be a lot more productive than for electricity.
And let me say that the use may be direct use right there on location. It may be within a facility, an industrial park, or maybe off taken to a community. Or if there's sufficient geothermal energy, it may convert to electricity for a regional grid, or maybe even the full electrical grid. I certainly agree with Carl. It depends on where the source and the wells are in the field versus the market. Geodynamics in Australia many years ago had a wonderful, wonderful geothermal field. Unfortunately, it was so far away from the market to provide the electrical energy for hundreds of miles across Australia, where there was no infrastructure, where it was not economical. However, there are many places here, not just in Texas, along the Gulf Coast, where we have direct use capabilities. We have facility use capabilities. We have capabilities amongst the industry here. So if we go from that arc of very South Texas with large communities, all the way through North Texas and along the Gulf Coast, actually the Panhandle of Florida, we've got tremendous geothermal resources and great potential uses of all types.
And I think I'll add too, Matt, you'd mentioned how, for oil and gas, we think of it marketing and we think of sending it down the line and you're sending it to a refinery that's going to a plant. I think there's a bit of a paradigm shift coming in our energy transition, in the sense that it really is a broader view of energy. And you really do think about energy in somewhat of a distributed manner, not in this, you have major plants that distribute the electricity, you send the fuel to the plants. Now the fuel and electricity are generated where it's needed. And so thinking about those use cases and how you combine all those parts and pieces. And there's a lot of modularity happening too. You hear about cryptocurrency mining out of, boxes, and you think about greenhouses, and you think about just use of where people are putting their infrastructure and thinking about where their energy source is. So I think there's a bit of a paradigm shift in how we really think about energy use and distribution of that energy.
That's a great point. I mean, one of the things that I love about science in general is that things are complicated. These are hard puzzles to solve, right? And I think you touched upon something that actually is important in all aspects, is we use one word to describe what we do: energy. Mm-hmm. But when we think about what that actually means, we do have everything from heating to electricity, which then branches off into a million other things. So if we actually drill deeper into that and try to understand, what are we using it for? How are we using it? Where are we using it? And kind of spinning off of that, does anybody on the panel know of marketing companies or companies that are actually matching, okay, here's the demand for energy, here's what they're using it for, and here's an instance where we can actually implement geothermal energy with that conversion? Does that exist, or is this up to companies, like Transitional and Serify to do at this point in time?
I think if I can just jump on that one, one of the three elements we looked at when we looked at getting into this space, was really how to de-risk the subsurface, i.e. the drilling aspect of it, because that's always been a big issue with geothermal, as the investors have, being sort of frightened off with the cost of drilling, etc. So, using existing wells, we look at them really, they're not dead assets. We look at them as exploratory wells, pre-drilled. So the well's already there that somebody's plowed a lot of money into. We know the temperatures, we know lots of information from that well, and effectively we can use them as like exploratory wells. They might not be the full development wells moving forward, but what they enable you to do is prove commercial concepts and sell something into somewhere to prove to an investor or stakeholders that there's other development. Then you can come along and drill specific wells you want for developing bigger scale, etc. And scale is what brings this or makes this work. So the other thing we looked at in this was the ability to deliver modular solutions on a case-by-case basis, but end up with the same result. So what we've done is built some software effectively, and there's probably others doing a similar thing, but software that enables us to look at every single well as a different scenario. So they might be standalone assessment, but at the end of the day, everything's modeled back to a standard plug and play solution. So we end up with a 5 or a 10 or a 20 or whatever it is in a multiple solution. And what that does is enables you then to modular its scalability and reduce risk. And what investors are looking for is a way to reduce risk, get return on investment at the minimal, problematic approach, but at the same time using as much off-the-shelf solutions as possible. So, this is where, again, where oil and gas comes into this. We've been doing this for a long while in oil and gas. We're experts at drilling wells, and there's lots of challenges in drilling wells, but we've been doing it for a long while. And if you can take away the mitigate these risks and make the commercial model a lot more attractive for investors, at the end of the day, this was what's scaling it up. And we'll only get better at doing this by doing lots and lots and lots of it. It's the same with wind. I remember 30 years ago when wind started, everyone was saying that's pathetic, putting windmills off the coast of the North Sea. Now we've got some of the biggest wind farms in the world there, and producing half the country's energy from them.
Yeah, I would agree that I think it's necessary to have companies kind of come into this space and be the system integrator. That's how we view ourselves at Transitional. And so we're kind of managing E&P operators who come to us and are looking for a solution for ESG goals or lower power prices. We have customers who need either heat or power, sometimes both. Those could be agricultural customers, those could be tech customers. They're maybe looking for a full-on development. Scale is critically important in those cases. And then we're also working with manufacturers who don't always know the use cases inside oil and gas. So we see ourselves as a system integrator. And I think for now, we would look like a service company in oil and gas, but we're called a developer over in the renewable space. So there's different words to kind of describe that. But it is necessary to have, Carl and myself kind of developing that space to help get this to catch on and move forward.
Yeah, that's great. So I guess sort of along that trend, I'd like to actually ask everybody this, but if you can divulge any details, that'd be amazing. Is based off of the maturity of your companies and your experience, what are the success cases that we can point to, or can we yet? And we're sort of in that appraisal mode. So I guess, Maria, what we can start with you is, based off of your experience, coming from an academic realm and being a resource for the geothermal community, have you heard of companies that have successfully converted an oil and gas well, whether that's from a technical standpoint or from an economic standpoint?
Yes, that we definitely have been doing that for the last 10 plus years. That we started out with the first one being up at Ormat, and the fact that Ormat Technologies in Ramatzi, which is in Wyoming, they were able to put a machine on and produce power from that low temperature, 190-degree temperature water. And then we also with SMU worked with the company Electrotherm and Gulf Coast Green Energy and their development of their technology over the different years, and watched them grow. And they were working with Denbury in Mississippi to take a well and produce power, as well as they've now worked up in North Dakota on their projects up there with Will Gosnold, and we're able to produce power from flare gas, as well as they're now working with Will on the project in Southwest North Dakota. And so that's another example where, yes, we have companies, and then we have companies, small companies who are startup, as well as we're all watching Sage Geosystems and hoping that they're going to be a brand new company coming in and develop new things. So the small companies have been in the beginning of this conversion of oil and gas and geothermal, with Ormat there in the beginning as well. And they have all continued to grow and expand. And surface technology is a big part of the success of this ability to convert wells at this point.
Excellent. Carl, do you based off of what you can divulge about your company, do you have specific success stories that you can point to, or sort of where you're at in your development?
Yeah, so I mean, we've as I said, we're coming up to a year old now, and we have currently 163 wells in the UK, which are sort of post production in abandonment phase 1. Out of them 163, we're probably looking at around 100 of them in total for various operators, and probably into detail of actually engineering at least 10 plus of them wells now for conversion. But I think, just to add to what Maria said, and we have to sort of step back a little bit, and although this might not have been done at scale before, every year there's 50,000 ground source heat pumps installed in the US, and all we're doing is the same thing but deeper. This is really using the same mentality, the same approach, but just doing it deeper and mining heat from the ground. That's all we're doing, and really, we make it sound simple, but that's effectively what we're doing. We're mining the heat from a well that's already there, that's been drilled, and we're just using that heat to produce energy. So I mean, most of the stuff is, although we also have some some patents and technology around the applications and the approach, but primarily it's not new novel technology. It's a different way of approaching and doing something. And I think this is like Sage, like other companies out there are doing this. We're all doing the same thing. We're just doing it a little bit differently, and we're all getting the same result at the end of the day, which hopefully is electricity, and hopefully is heat, and hopefully is all these other things. And to be honest, we need 10, 15, 20, 30 more a week, because if we're going to do an impact and make it change in the way this energy is being used, there's going to be thousands of Seraphies, thousands of Sages, thousands of this, and we still won't make a dent in what's needed to be done. So I think the opportunity is massive, and we're just really, again, along with everyone else on this panel, and even for this whole week, is really just trying to advocate for what geothermal can bring to the world. And we're all just doing the same thing, just doing it differently, and bringing a different tool in the toolbox to the party to make it work.
Well said. That's great. I mean, that's coming from UK, so you're across the pond from the US. And Selena, like from your experiences in the US here with your company, can you comment on successes or any challenges that you've had like currently that you can point to as far as that moving forward?
Yeah, so I think there's also a discussion around the broader market view. So in Europe over the last decade, there's been a lot of movement in renewable portfolio standards. The US now finally is there on the renewable portfolio standards. And when that happened, that really shifted a lot of technology changes. So this kind of idea of capturing heat or heat waste is not new. It's been done in many other industries, usually from engine waste or boiler heat waste. In power plants, in geothermal power plants. And so heat waste is just something that we capture all the time in a variety of industries. So it's not new, it's just an application that's a little bit different. In the US in particular, so Canada also, there's a company up there that started doing this kind of low temperature sedimentary geothermal. And I would say that one of the challenges in the US is the structure of all of our regulatory environments, that it's very, very localized. So you get into these local co-ops for the utility, or you get into larger, bigger utilities, or you get into BLM lands, or you get into, there's lots of layers that kind of add up into that. And so one of the things that we really look at when we go to look at projects, we have a number of clients, there's 10 or 15 clients in California, Nevada, Wyoming, the Bakken, Colorado, so a little bit everywhere. And I think, one of the things we really look at is where can you sell that heat or power and/or power. So that's probably the biggest factor, and that gets pretty complicated. So it just takes time and it takes persistence. And it's not that, figuring out the hot water and the subsurface always feels like the easiest part for me as a reservoir engineer. It's all of the other stuff. I can see why it has taken a while to come to fruition, especially because the last decade here in the US, we were focused on the shale boom. And so our capital dollars were just going somewhere else. And now that we have different goals in front of us, I think our focus is maybe a little different, and the innovation will come from that.
I think I'll just to add to that as well. I think, we're seeing that the people who own these wells, the operators, they all have different agendas. So, they might want to sort of co-develop assets. Smaller companies might want to sort of just offset them and have somebody else look after them. So you do get into these, and we have this sort of issue in the UK, and we've also, had similar discussions across the Railroad Commission and these sort of things in Texas. But having the liability, transferring the liability of its end of its life is not an easy discussion to have with a regulator. So we have to, bear that in mind. So what we're really just doing is extending the life. But I think there's also, a part of this that we also are missing, and that's actually looking at how do we get involved in new developments that are being done to actually plan in all of these things we're talking about now for reuse from the beginning. So actually you do have an actual transition of energy from the beginning that's actually built into a project. And these are, discussions we're now having with operators here in certainly in the UK, and sort of engineering EPC contractors and that about, planning in for the future of so you don't have decommissioning at the end, you just have a transition, and this is really, I think, the important discussion, because remember, we're this is, we're looking at wells that are generally 20, 25, 30 years old, but 20, 30 years down the road, these are all be new wells that we're looking at. We need to be looking at how do we do, the wells aren't going away, we're adding 50, 60,000 every year. So
yeah, that's great.
Yeah.
Bob, can you comment on, from your perspective, more from that drilling execution side, like what successes, if you can, tell us what you've been involved in?
Yeah, a number of different projects. First of all, there's really three big issues. The first one, of course, is technology and the development of new technology, which always gets us to better economics and gets us to quicker and better wells. And this is both on geothermal wells and geothermal fields, as well as oil and gas wells and fields that might be for geothermal repurposing. And the better technology comes across in better drilling technology, certainly with completion technology. Downhole heat exchangers is a technology that continues to develop, is available today, and provides more effective and efficient heat harvesting to get that heat to surface, no matter what the when you couple that with more efficient heat transfer technology at surface, we can look at the full continuum, which helps the full economics of the project to whatever the final purpose would be. And then finally, the regulatory scheme is so unfortunate when you're talking about places like California, where and some other areas where the potential is so high, the resources there, we understand that. However, trying to get permits is really, really tough. That's why in places like Texas and oil gas areas, the rights are known, the permitting is there. Many times the wells have the exact same regulatory requirements, and it's easier to do it on private land than, let's say, federal land. So if a resource of a geothermal target exists on or nearby an oil and gas field, and almost anywhere in the world, it makes it so much easier to develop that for geothermal resources because the rights are all there.
So would you say that from a, because especially in Texas, right, regulatory is the engine that sort of, can either hold us back and stall or help us push forward with oil and gas development. So from a geothermal realm, in the permitting and the utility from that aspect, like, can you reuse those permits, or, is it an easy process to go from oil and gas to geothermal, or are there additional hurdles? And, we can start off with Selena and Bob and then move to Carl for more of that global view, because I'm sure that the regulatory issues are different between the two countries.
Well, I'll just mention, sorry, Selena, I will mention the Texas Railroad Commission. Well regulations are virtually the same as oil and gas.
Yeah, and that's most the case, I think, across the US. There's sometimes geothermal is regulated by the same group that regulates oil and gas. Sometimes it's not. There's still the aspect of geothermal leasing, just like there's oil and gas leasing. So you need to have some leases around that. There's also other permitting when it comes and thinking about how you're then selling back into the grid, for example. There's different regulatory requirements around that. What I would say is that part of our role at TE is to really think about working collaboratively with those regulatory bodies that, we're all going through the energy transition. It isn't just one company or one group, it's everybody. And so it's going to take all of us working together and putting the solutions in place so that we can actually transition and think about it and doing it a safe way, doing it with the least impact to the environment. I think those are important things and something that we're capable of doing, but it will take a collaborative effort, both from an operator standpoint, service company standpoint, utilities, as well as regulatory bodies.
I also think there's also I think sometimes we use the word geothermal very loosely, and there's a perception of geothermal, and everyone has a different one from what I understand. So generally when we speak about geothermal and we're talking to a regulator who's, vaguely, involved with geothermal, they look at it from different ways. And I think sometimes our messaging needs to be a little bit more descriptive in what we actually mean when we talk about, geothermal from the point of repurposing a well or drilling a new well, etc. Because there's a lot of confusion in some of them discussions sometimes, and even in just the wider, perception of, we look at, the use of heat under the ground, anything from the subsurface down, which includes really ground source heat pumps and all that sort of stuff. And, then you get into sort of deeper geothermal, etc. Other people's wells are different. So they don't class, ground source heat pumps as the same as geothermal in the same language, but at the end of the day, you're still using the heat, So I think there's these sort of issues that, we're finding. And I think as you move around the world and look at different, jurisdictions, actually, I think Texas is probably, from a point of view of doing things, is a lot easier to do things in Texas, as Bob and Selena have said. I think we find in general discussions there seems to be a lot more of a liberal approach to be able to repurpose a well for doing something else, as opposed to, say, going somewhere in Europe or somewhere else that where the regulations are a little bit more stricter. And also in places like the UK and in Europe, we also still have you know, a lot more challenging issues even with the conventional geothermal approach, because you know, there's a lot more sort of areas opposed to things like, you know, hydrotesting and or fracking as they call it. Whereas in the US, it's, you know, it's a pretty done thing. Nobody really worries about it. But, you know, so I think where you go and what you do is changes considerably, and we have to be conscious, and everything we do is about, you know, trying to educate people in different areas about, you know, what we're actually doing. And that's a really important part of this whole process, I think, to make it scale and move forward.
Great.
Yeah, I always say we're mostly just corporate translators, as sometimes it feels like, in getting everybody on the same page using the same language. Like, do you mean the same thing I mean?
Yeah.
Matt, I'd like to throw in there that one of the things about international is that both China as well as Colombia are two different countries that are converting oil fields. And so by having that country government support is a game changer in that respect. And hopefully with the United States, you know, with the Biden administration right now, we might have an opportunity to develop more than what we did in the past.
Yeah, so I'd like to transition, because this has been great content, I think, for understanding, you know, where can we go, the complicated nature of the geothermal, you know, conversion of oil wells, and, you know, everything from regulatory to how do we think about energy, how should we think about energy in the utility. But one of the things from an oil and gas background, and paying attention to the panel so far, the other panels, is the idea of flow of the water. And so a lot of times in oil and gas, you know, sort of like, you know, everybody has suggested, is we don't plan for geothermal conversion. Maybe that will be a future implementation in it, but oftentimes the idea of the casing is much smaller than the geothermal industry would prefer to get those flow rates. And then you couple that with the potential cold basin or the lack of, you know, resident heat within the formations. Is there, you know, how can we overcome that? Do we need to overcome it, or do we just sort of take that as a case-by-case basis? I would love to hear everybody's thoughts on that idea of the restricted nature of oil and gas development, and how we can think about converting these wells over.
Okay, do you want me to go first again? Or?
Yeah, Carl, go ahead. Sorry.
Well, I mean, yeah, it is a case by case. You know, like we said, and I think we all agree with that. You know, it's there's no sort of one well that's you know, we can say this is the perfect well. It's all about temperature and the actual completion size. And you know, we've got to, you know, put our hand up and say there are going to be wells that we can't do anything with. You know, and we can't do nothing with. And you know, but the thing is, it's quickly assessing them wells and actually saying, you know, these wells aren't suitable. You know, what we don't want to be doing is just going into wells again. Well, certainly our approach is not to go into wells again and start doing workovers and stuff like that, because once you get into that space, you might as well just drill a new well. You know, it's more of a you know, a much easier economic approach with less risk to just drill another well than it is to start messing around with a well that's you know, 20, 30 years old. So you know, and we do see, you know, lots of discussion with companies that have gone and tried to do that, and you know, and invariably there is some failure involved in that process along the line with from experience. So you know, we look at the wells, we make a quick assessment very quickly and understand, you know, model what can be done, what can be achieved, and you know, make an executive decision on whether it's, you know, whether there's a commercial business case there or not, and that can be done pretty quickly, you know, in a matter of days and weeks, to come up with a pretty solid business case to give somebody you know, a green light on whether they want to throw money at it or not. You know, or not, you just walk on and to the next one, you know.
Maria, do you want to go ahead?
Sure. So from working with Petrolearn as a consultant with them for the last year, that they have been really showing the fact that economically you can start converting wells over to geothermal energy with just co-production. And that's one of the things they focused on, is doing, is, you know, like Carl, you're right, that if you're trying to go into wells and change them, it gets to be very expensive. So there are opportunities specifically for that well bore to be converted as is, and those exist right now worldwide. And so I want to point that out, in that so there's an example where we do have the economics, we have the surface equipment, and that might be an easy starting point for some people who are trying to say, what can I do with my water and, you know, as a produced fluid.
Is there a concern about, quote unquote, contamination between the water that we would use, or, that's being utilized for the geothermal, and then the oil or the hydrocarbons that are coming out? I guess that would be dependent upon the system. Is it an EGS system, or is it sort of like an open system?
I mean, from our approach is very much, again, looking at, we produce water all the time in oil and gas wells. It's just normal. So and temperature just adds a different ratio to that when you're dealing with the sort of geothermal flows. Like Maria said, being able to use the hot water to produce electricity at the right temperature, you need to be looking at sort of 120 plus degrees to do that, to get sort of efficient electricity. But you can still, even with the water systems we're looking at, you can still do things like desalination at sort of around 80 to 100. And you can actually take salt out of systems. You can clean up water. You can do water treatment. You can do lots of things like that, which actually makes the water usable for other things, whereas it wouldn't be usable, generally for any useful purpose. So I think it's a combination of really, what the well is, what can be used, what can't be used, and how we approach it. And I think what you mentioned about the for each system itself, we just need to look at individually and make sure that we can actually either apply something for use commercially or not.
And I think of geothermal co-production as an enhanced energy recovery, a lot like enhanced oil recovery. You're solving a different kind of problem, and you have another set of variables or another side on your sandbox that you're working in. And I think that the idea of it almost reminds me of a little bit of the circular economy conversation that happens around, let's think about everything that we're putting into the ground and designing and planning for that, and planning for what comes next after that, and think about the cost benefit analysis of that, and thinking about what makes it easier later on, or what we need to include now. When I was at Thumbs, we would plan for ESPs to go in every single hole. You'd also plan for them to be converted from production to injection, and those maybe have different wellbore designs associated with them, and that could happen in a co-production facility. So man, it would sure make my job easier at TE if everybody was already planning for it. I think figuring out how to convert is where that innovation will come from, in figuring out how to plan for the next stages. So I just think it's really cool and really exciting for everybody to start thinking about that enhanced energy recovery, or energy pads, if you will.
Yeah, I think in all subsurface resources, and geothermal as well as oil and gas, where do we start? Well, let's look at the rocks and see where the resources lie and what they are. Try to quantify those and overlay what the rights are to target and get to those resources. And then the configuration and the types of completions to get the resources captured, harvested, brought to surface most efficiently, and then use them. And that's your economics, because whether the final product, again, is direct use, whether it's oil and gas to convert to hydrocarbon products, which are extremely valuable. Maybe it's just hot water, which you can use for other purposes and re-inject. And of course, conversion to electricity. The whole value stream has to be looked at, and that's the project. And the continuum is the key, of course, for any resource development.
That's great, Bob. I have some unfortunate news, and that is our time is coming to an end for this session. I feel like we could probably spend another 24 hours on this topic and fielding questions. I do want to thank everybody on the panel for their time, and also for their insights on everything. One thing that I think we can all take away is that, like most things in life, things are complicated. However, it doesn't mean they're impossible. We just need to be innovative and to use what we have, and to work together in understanding how to overcome those solutions. And with that, I just want to offer all of the panelists a 1 minute, just a brief, closing statement that you'd like to give to everybody, and we can start with Selena first.
Yeah, so first of all, thank you for having us on the panel. It's been really great. I look forward to staying connected with the other panelists and continuing the conversation outside of this forum. I thought this was really wonderful. I think that the collaboration is really what's going to drive that innovation. And I'm just really excited to get in and solve those complicated problems. We're all going the same direction with this energy transition. And there are some really smart people coming along with us. So thank you. And I feel very privileged to be part of this group.
Well said. Thank you. Maria, if you'd like to go next.
Sure. So this has been a lot of fun, and I appreciate, and I'm thrilled with Jamie's success and Bob Metcalf and just what you guys are all doing. So thank you for that. But along with it, I want to throw out an inspiration and one of my goals, which is the city of Houston has said that they want to be carbon neutral by 2050. And right now they're focused on solar. But Houston, Texas is the capital, in my mind, of oil and gas. And so I would like to see the city of Houston, the oil and gas industry and the geothermal industry coming together and helping the city of Houston become carbon neutral faster with geothermal energy.
Well said. Absolutely. Yeah, that goes into the theme of using all your resources, not segregating them.
Right.
Yeah, Bob, would you like to go next? Any closing remarks?
Sure, more than happy to. The most important thing, I think, is geothermal is continuous baseload energy, and the world needs that. Yes, all the above as far as energy for this country, the world, all societies is absolutely important. And geothermal brings in the continuous space load without many of the environmental and other hassles that can arise. Along with that, if you're looking at it from an investment standpoint, it's a key ESG component for resource development.
Excellent. Thanks, Bob. Carl, we saved you for last since it's the latest where you're at. But if you'd like to make some closing statements.
Yeah, I mean, very simply, thanks again for everyone on here for this discussion. It's been great, and look forward to more of it. I think my sort of final words are whatever we do in this space moving forward to make it more efficient, better, to get this wonderful baseload energy to a scalable global use and all the benefits that come with it. We have to remember that without making it commercial and without making it profitable for, at the end of the day, stakeholders, and that profitability doesn't have to always be liquid. It can be the values of ESG, as Bob mentioned, and other things. But it has to make commercial sense for it to work, and we need to. The quicker we can get away from what I call science projects to a certain extent and get into real commercial projects where people can actually see physically see returns on this and actually prove scalability and growth, the quicker this whole thing will move and investors will get behind it. And, as Maria said, why are we looking at solar in Texas? Why are we even looking at it in the UK? Why do we look at wind in the UK? We've had an oil and gas industry here for the last 70 years, the same as Texas has had it for over 100. I think we just need to prove the commerciality of it for it to work, and I think everyone I think over the the next few years of doing these events every year and that we will do that, and collectively it will work, and we will get the support of the people that really got the money and make it work, because it's money that's going to drive it.
Thank you. I appreciate everybody. And just one closing remark is that I've learned a lot, and being in the oil and gas industry and seeing that evolution of the industry since I've been here, and those costs come down, with panelists like yourself, and really with the whole conference and everybody working on this, I see that geothermal definitely has a place, because in order to provide energy on a global scale, we're going to need multiple sources, and continuing to work together and to go towards that common goal is definitely key. So I'd like to thank everybody and close out this session.
Thank you, everyone.